Alright, so now I want to talk about section 4.8, which is all about applications and models of right triangles. And so I just want to talk about a few of these, a few different things about triangles that we know to be true, and then just kind of revisit some of those trig relations and to make sure that we can apply it to actually solving some questions here. Okay, so a few components about triangles. First off, they sum the angles, sum to 180 degrees. Okay. We're dealing with right triangles here most of the time. So right triangles have a 90-degree angle. Okay. And then, since we're also dealing with right triangles, the Pythagorean theorem holds. Okay. So let's look at an example of a right triangle here. And let's label it, let's go with A, B, and C. And then capital A, capital C, capital B. Yeah, and this is with a 90 degree. All right. So the goal of this section is to be able to be given a few items and to be able to just fill in the rest using our trig identities. Okay, so just remember our main trig identities are sine of theta is opposite over the hypotenuse, cosine of theta equals adjacent over the hypotenuse, and tangent of theta is equal to opposite over adjacent. Okay, so let's say here that I give you that the angle A is 60 degrees. Okay, and I'm going to give you that the hypotenuse has a length of 16. So now our goal here is to fill in all of these other values. So I need something for lowercase a, lowercase b, capital B, capital C. Okay, well, capital C, I know that is 90 degrees because I'm given that. All right. But to find B, I know that they need to all sum to 180 degrees. So that is to say that 60 plus 90 plus my capital B should all equal 180 degrees. Okay. So with just doing a little bit of algebra, I can find that B is equal to 30 degrees by solving for B. Yeah, so I've discovered that. All right. The other side, what about, let's look at A. Okay. So I want to find A. Well, depending upon which angle I choose, here I'm going to choose capital A. That is the opposite side of the angle 60. So I would need my opposite and my hypotenuse, since I have a hypotenuse of 16. Okay. So I would say that the sine of 60 is equal to opposite A over the hypotenuse of 16. Okay. Do some algebra, multiply over. So 16 sine of 60. You want to make sure that your calculator is in degrees. Okay, we don't want radians here, we want degrees. So I plug that in the calculator and I get that A is about 13.86. Okay. You would do a same situation for B. And then if you wanted to check your answer, you could do the Pythagorean theorem and say A squared plus B squared should equal C squared. Okay. So that is just an example of one. Let me show you something that if we're not given a right triangle, like let's say that we're given an isosceles triangle. Okay. And let's say that it has measures of 20 degrees here and here, and a base length of 18 degrees. And I was tasked with finding what's called the altitude or the height. Well, I may not know exactly what that is just yet, but if I look, it looks like I have a right triangle. Okay, so I want to draw a right triangle to represent that half of the isosceles. This angle is still 20 degrees. This is 90. My height is x. Since I have cut my triangle in half, then I've also cut my base in half and call it 9. Okay. Now my relation to this angle 20 is my opposite side over my adjacent side. So I go back to my trig identities, and my trig identity is the tangent of theta that corresponds to opposite over adjacent. So I'm going to say that the tangent of 20 degrees is equal to my opposite side over my adjacent side. Okay. Do the algebra. I get that 9 times the tangent of 20 is equal to x. Okay. Then I would plug that in the calculator. All right. And then whatever the calculator gives out is, let me plug in the calculator real quick. So I have 9 times the tangent of 20. Which is 3.28. So 3.28. Okay. All right. So this is enough. Just knowing these two skills is enough to get you through section 4.8. Just draw a picture. That's the key component. So draw a picture to represent a right triangle. Let me know if you have any questions. And as always, have a great day.